Welcome to the Pro Ticker Deep Dive. I'm really excited to get into this one today because we need to talk about the numbers.
Oh, yeah. The numbers are, there's something else right now.
They really are. And I don't just mean the standard quarterly earnings beats or the,
Yeah.
the typical guidance updates we usually parse through here. I'm talking about capital expenditure numbers that frankly look like typos.
Great. You're looking at the Amazon projections.
Exactly. I was reviewing the CapEx projections for Amazon for the fiscal year 2026 this morning, and I actually had to go back to the source documents. I thought I had misread a decimal place.
You're referring to the $200 billion figure.
$200 billion, yes. That is Amazon's projected spend for 2026, which is a 53% increase year over year.
Sure.
And to put that into context for you listening, because I know you track these things,
Yeah.
that single figure is larger than the combined capital expenditure projections of Alphabet, Microsoft, and Meta for that exact same period.
It is an absolute mountain of capital.
It's historic, right?
It really is. We are witnessing an industrial mobilization that honestly rivals sovereign nation spending. But you have to look past the sticker shock to understand the underlying strategy here.
Because they aren't just building more warehouses.
Exactly. They are building more fulfillment centers or buying another fleet of Rivian delivery vans. This is almost entirely allocated to the physical foundation of artificial intelligence. It is an arms race, plain and simple.
But see, an arms race usually implies two sides with roughly equal firepower. And that's the tension we really want to unpack in today's deep dive. We're calling this the Silicon Schism.
I like that term.
Thanks. Because for the last decade, and certainly since this massive generative AI boom began, there was really only one arms dealer in town. If you wanted to play the game, you paid the toll to NVIDIA.
Correct. NVIDIA has been the singular choke point for the entire industry.
But now you have the challengers stepping up. Specifically, you have Amazon Web Services deciding that writing a massive check to Jensen Huang every single quarter is no longer a viable long-term business strategy.
They are deciding to build instead of buy.
Right. So we have this massive conflict brewing. The incumbent king, which is NVIDIA, sitting on a $4 trillion market cap, versus the challenger AWS with this $200 billion war chest.
And it is so much more than just a vendor dispute or a pricing negotiation. It is a fundamental philosophical clash regarding the future of computing architecture itself.
How so?
Well, on one side, you have NVIDIA, representing what we call general-purpose versatility, the GPU that can do graphics, it can mine crypto, it can fold proteins for medical research, and, of course, it can train massive large language models.
It's a Swiss Army knife.
Exactly. But on the other side, you have this aggressive pivot toward application-specific efficiency. AWS is betting that in a world where AI becomes integrated into absolutely everything, you don't need a chip that does everything. You need a chip that does one thing perfectly.
Okay, so let's start with the incumbent. We need to set the stage with NVIDIA because I think for a lot of you listening, it's easy to get a little bit of fatigue hearing about them. We know they are huge. We know the stock is up. But we really need to look at the mechanics of their dominance to understand why Amazon is trying so unbelievably hard to break it.
Well, as we sit here late in 2025, heading into 2026, NVIDIA's grip is effectively absolute. We are looking at market share estimates for data center AI chips ranging anywhere from 80% to 94%.
Which in antitrust terms is usually exactly where regulators start sharpening their knives.
Oh, absolutely. It is a functional monopoly. And the broader market has priced it exactly as such. I mean, in October of 2025, NVIDIA touched a $5 trillion market cap. They literally became the most valuable company in human history.
Insane.
It is. But the valuation is actually secondary to the mechanism of control. If we want to understand the Silicon Schism, we need to talk about the NVIDIA tax.
Right, the premium. But let's be really specific here for the audience. When we say tax, we aren't just talking about a high gross margin on a piece of hardware. We are talking about the total cost of ownership. So why are incredibly smart CIOs and CTOs willing to pay a 73% gross margin to NVIDIA when they could arguably get silicon elsewhere?
Because the physical silicon is actually the smallest part of the equation. This is the moat that everyone talks about on financial television, but rarely dissects technically. It is CUDA.
The Compute Unified Device Architecture.
Yes. But think about what that actually means in practice. CUDA isn't just a basic programming language. It is a massive, dense ecosystem of libraries, compilers, and optimization tools that has been compounding since 2006.
Almost 20 years.
That is 20 years of software sediment. If you are a researcher at OpenAI or you're a scrappy startup in San Francisco, every single tool you use, whether that's PyTorch or TensorFlow or the deep kernels that manage your hardware memory, it is all optimized for CUD first.
So the lock-in isn't that the H100 or the new Blackwell chip is magically better at doing basic math. It's that if you try to use something else, your code literally breaks.
Or even if it doesn't break entirely, it runs at maybe 50% efficiency because the compilers just aren't optimized for that alternative hardware.
Yeah.
It is like trying to move your family out of a house where all the furniture is bolted to the floor.
That's a great analogy.
You can do it, sure, but you have to rebuild every single piece of furniture from scratch once you move. That friction is exactly what allows NVIDIA to charge that massive premium. You aren't paying for the physical chip. You are paying to not have to rewrite your entire software stack.
And NVIDIA knows this. They aren't just sitting still resting on their laurels. The hardware roadmap we are seeing from them is relentless.
It is punishing for their competitors. They have moved to a one-year product cycle, which is grueling. We saw the Blackwell architecture launch, specifically the B200.
Let's talk specs on the B200 for a second, because the numbers are frankly absurd.
They really are. 208 billion transistors.
Just pause on that. 208 billion tiny switches on a piece of silicon.
Right. But the important thing isn't just the raw transistor count, it's the architecture itself. Blackwell is essentially two massive GPU dies connected by a 10 terabyte per second link acting as a single unified chip. This was designed specifically from the ground up for the era of trillion parameter models.
And they're already teasing the successor,
Right.
the Vera Rubin architecture.
Right, moving to a 3-nanometer process technology. But the really interesting thing is how the pitch NVIDIA is making to these hyperscalers, to your Amazons, Microsofts, and Googles, how that pitch has fundamentally changed. They aren't selling graphics cards anymore, they're selling AI factories.
Yeah, I saw that exact term in their 10K filings, AI factory. And I have to be honest, it sounds a lot like marketing fluff.
It definitely sounds like fluff at first glance, but financially, it is a brilliant pivot. NVIDIA is essentially telling these massive buyers, don't look at the upfront cost of the chip, look at the revenue of the computational output. They argue that a $5 million investment in a GB200 NVL72 rack, that is their massive rack scale system, that $5 million can generate $75 million in token revenue over its operational lifespan.
So they are pitching a 15x return on investment.
Exactly. They are shifting the entire conversation in the boardroom from CapEx cost to revenue generation. They are saying, sure, we tax you heavily up front, but we make you rich on the back end. And frankly, as long as the global demand for AI inference and training remains infinite, that math holds up perfectly.
But does it hold up forever? Because that brings us directly to the challenger. If the math held up perfectly and efficiently, Amazon wouldn't be spending $200 billion to build their own alternative. Clearly, the math has started to break down for them somewhere.
The math breaks at scale.
Explain that.
When you are a mid-sized tech company renting a few hundred GPUs, the NVIDIA tax is just the cost of doing business. You pay it and move on. When you are Amazon deploying 500,000 chips across global data centers, the NVIDIA tax becomes an existential threat to your core operating margins. That is precisely why AWS is going vertical.
Vertical integration, the classic Apple playbook. Control the hardware, control the software, control the costs.
Precisely. AWS has split their custom silicon strategy into two distinct lines. You have Inferentia and you have Trainium. And the naming convention is refreshingly straightforward. It tells you exactly what they're built for.
Inferentia is for inference, running the AI models once they're already trained. And Trainium is for the heavy lifting of actually training them from scratch.
Correct. And we really should start with Inferentia, because right now that is where the real volume is. For a lot of enterprise businesses, the training phase is a massive but one-time event. But inference is forever.
Every single time you ask a chatbot a question or generate an image that is inference.
Exactly. And AWS claims that major enterprise companies like Qualtrics and Finch Computing are seeing 40 to 80% cost reductions by moving their inference workloads from traditional NVIDIA GPUs over to AWS Inferentia chips.
40 to 80% is not a rounding error. That is massive margin expansion.
It is game-changing. If you are a SaaS company and your compute bill is your second largest line item right after employee payroll, cutting that compute bill by half fundamentally changes your company's valuation.
Sure.
But the real battle, the one that really matters for the long-term future of AI dominance, is training. That is the prestige game. That is where NVIDIA is seen as virtually untouchable, or at least they were.
Which brings us to Project Rainier. I want to spend some real time here because the physical scale of this project is extremely difficult to visualize. This isn't just a big server room somewhere in Virginia. This is essentially a planetary scale computer.
Project Rainier is AWS's declaration of war. It is an ultra cluster activated by AWS in late 2025. We are talking about a single unified mesh of nearly 500,000 Trainium2 chips.
500,000 chips acting together.
Yes. And to give you listening an idea of the density here, usually these high-performance clusters are measured in the tens of thousands of chips. 500,000 is an absolute engineering marvel just in terms of pure power delivery and water cooling. But the real headline here isn't just the hardware itself. It is who is actually using it.
Anthropic.
Exactly. Anthropic is using Project Rainier to train Claude. And this is critical market validation. If Amazon was just using these custom chips internally to optimize their warehouse robotics or their e-commerce recommendation engine, nobody in the broader market would really care.
Right, would just be an internal cost-saving measure.
Exactly. But Anthropic is building absolute frontier models, GPU 4 class and beyond. By choosing to train on Trainium, they are proving to the world that AWS Silicon is fully capable of handling the most complex mathematics currently known to computer science.
I recall one of the source documents using an incredible analogy about the speed here. They said that counting from 1 to 1 trillion would take a human being 31,700 years.
Right. It's an unfathomable amount of time.
But a single Trainium2 chip performs the exact calculation instantaneously. And now we are talking about networking 500,000 of them together. But I want to push on the how here, because you can't just plug 500,000 ultra-fast chips into a wall socket and expect them to talk to each other. The networking bottleneck usually kills these massive cluster projects long before the chips themselves max out. How exactly is AWS solving the interconnect problem at this scale?
This is where the custom silicon advantage really shines through. Because they aren't just designing the math processor, they are also building the entire network interface from the ground up. They use a proprietary technology they call Neuron Link.
These are the famous blue cables?
The blue cables, yes, as they are affectionately known in the data center. But technically speaking, this is a direct chip-to-chip interconnect. In a standard traditional server setup, if chip A wants to share data with chip B, it often has to route that data through the central CPU or through a standard PCIe switch.
Which acts like a traffic light, adding latency.
Exactly. It adds microseconds of delay, which at this scale is fatal. Neuron Link allows the Trainium chips to bypass the CPU entirely and share memory directly with each other.
So it creates one massive shared memory pool across the rack.
Effectively, yes. Within the server rack, those blue Neuron Link cables create incredible internal speed. But then, to connect the individual racks to each other across the massive warehouse, they use something called the elastic fabric adapter, the yellow cables.
Right.
This two-tier proprietary networking architecture is exactly what allows them to scale linearly. Usually in computing, when you add more chips, you get diminishing returns on performance because of traffic jams. AWS is claiming they have successfully flattened that curve.
Okay, so they have the physical scale, they have the networking with the blue and yellow cables.
Uh-huh.
But let's zoom back in and talk about the actual chip itself. Because for a really long time, the industry knock on AWS custom chips, and frankly on Google TPUs as well, was that they were good enough for internal budget workloads, but they certainly weren't state-of-the-art. They were essentially the budget option.
That was the prevailing narrative, yes. Trainium2 was a very good chip, but nobody was calling it an H100 killer. But Trainium3 fundamentally changes the conversation. This is the new heavyweight contender. And the key word you need to focus on here is parity.
Parity. That is a very dangerous word to throw around when you're comparing yourself to NVIDIA's flagship products.
Yeah.
You'd better have the independent benchmarks to back that up.
Oh, they do. The new Trainium3 Ultra server is matching NVIDIA's flagship GB300 NVL72 system at the full rack level. We are talking about 0.36 exaflops of compute power per server rack.
Okay, let's pause on exaflop S. I know our audience is highly technical, but let's really ground that number for a second. 0.36 exaflop S. What does that actually mean in terms of raw real-world capability?
An exaflop is 1 quintillion floating point operations per single second. That is a 1 followed by 18 zeros. To put that into historical perspective, the absolute fastest government supercomputers in the entire world only managed to break the 1 exaflop barrier a couple of years ago. And now, AWS is casually dropping a third of an exaflop into a single standard commercial server rack. It is an incomprehensible amount of density.
And this new architecture is built on the 3-nanometer process, right?
Yes, utilizing TSMC's cutting-edge 3-nanometer nodes, which is a huge deal because this puts AWS on the exact same advanced manufacturing footing as NVIDIA's upcoming Vera Rubin chips. So the narrative shifts. It is no longer older tech for a cheaper price. It is now cutting-edge tech for a cheaper price.
How much cheaper exactly? Because if the absolute performance is genuinely the same price, it becomes the only real lever left to pull.
AWS claims the Trainium 3 architecture offers 4.4 times faster performance than the previous generation Trainium 2. But more importantly for the CFOs, they are projecting 50% cheaper training costs compared to a comparable top-tier NVIDIA cluster.
50%.
Cut the compute bill entirely in half.
So if you are a red-hot AI startup, you're
Right.
raising a massive Series B round, and you know you need to train a foundation model. One cloud provider tells you it will cost you $100 million in compute. And AWS walks in and says, we can do the exact same run for $50 million. That is not a hard decision to make at a board meeting, assuming the software actually works.
Exactly. And assuming you can actually get the power to run it, which we haven't even touched on yet, the energy efficiency aspect of the schism.
Let's get into it, because power is the massive bottleneck right now.
It might actually be the sleeper metric that dictates who wins this entire decade. Data centers globally are literally running out of power. We are seeing hard grid capacity constraints in places like Northern Virginia and Ireland. You can't just plug more racks in.
Right. The utility companies are saying no.
Precisely. So AWS designed Trainium 3 to be hyper-efficient. They claim it delivers 5 times higher output tokens per megawatt compared to legacy hardware.
Tokens per megawatt. That is effectively the new miles per gallon for the AI industry.
It absolutely is the new miles per gallon. In a severely power-constrained world, absolute efficiency is absolute performance. Think about it. If I own a 100-megawatt data center facility and I can squeeze 5 times more artificial intelligence output out of that exact same building using Trainium versus a legacy GPU setup, I win the market.
Because it doesn't matter how fast an individual NVIDIA GPU is if the utility company won't give you the electricity to turn it on.
Exactly.
Okay, so let's summarize where the challenger stands. AWS has reached performance parity. They have a massive 50% lead in pricing. They have a 5x lead in energy efficiency. If I'm sitting in the executive strategy room at NVIDIA right now, I am sweating. But then just as AWS has the momentum, they do something completely weird. They announce Trainium 4. They announce a strategic twist that seems completely counterintuitive.
You're talking about the pivot to interoperability.
Right. AWS announced that their next generation Trainium 4 chip, which is expected sometime in late 2026 or 2027, will natively support NVIDIA's NVLink fusion technology. Now, correct me if I'm wrong here, but isn't the entire point of spending $200 billion to build your own custom chip to permanently replace NVIDIA? Why on earth would you engineer your brand new chip to plug directly into your biggest competitor's proprietary network?
This is where the long-term strategy gets really sophisticated, and it strongly suggests that AWS management knows they cannot outright kill NVIDIA, not yet anyway.
It almost feels like a quiet capitulation.
I wouldn't call it capitulation, I would call it intelligent containment. AWS is looking at the market and realizing that the developer ecosystem is deeply bifurcated.
Explain the hybrid cluster concept for the audience. How does that work in practice?
Imagine you are running a massive months-long training run for a new model. Maybe 80% of the sheer math involved is just brute force tensor operations that can be done incredibly cheaply and efficiently on AWS Trainium chips. But maybe 20% of your pipeline involves some exotic operator or a very specialized physics library that is only deeply optimized for NVIDIA GPUs.
Okay.
In a hybrid cluster, you don't have to choose one or the other. You can mix AWS chips for the cheap grunt work and physically plug in NVIDIA GPUs for the highly specialized work, all functioning together within the exact same high-speed network fabric.
So AWS is essentially commoditizing the GPU. They are treating NVIDIA hardware like a very expensive high-end spice that you just sprinkle on top of the dish rather than forcing you to buy it as the main course.
That is a perfect way to put it. They are deliberately positioning AWS as the universal infrastructure layer. They want to be the agnostic platform where all silicon from any vendor works best. If you have the budget and you absolutely want to use NVIDIA, fine, plug it in and use it on AWS. If you want to use Trainium for the bulk of it, great, it's 50% cheaper.
So by making the hardware totally mix and mash, they systematically reduce the industry's absolute dependency on NVIDIA as the sole end-to-end provider. They turn the almighty GPU into just another swappable server component.
Exactly. That is a very dangerous game for NVIDIA to be pulled into, because if their hardware just becomes a component in an AWS rack, they lose that end-to-end ecosystem premium. They lose the justification for the NVIDIA tax.
That is the long-term existential threat. But NVIDIA obviously has a massive defense. And to understand it, we have to circle all the way back to the software side of the house. Because we can sit here and talk about exaflopius and 3-nanometer nodes and blue cables all day long. But if a software developer fundamentally hates using the AWS chip, it simply won't be used. So we need to evaluate the Neuron SDK versus CUDA.
The software battlefield. This is where all the bodies are buried in this industry.
It really is. And we have to be completely honest here with our listeners. The AWS Neuron software has a reputation, and it's not always a glowing one.
No, it's not. I've heard the same horror stories you have. Kernel panics in the middle of a run. Documentation pages that lead straight to 404 error links.
Debugging simple errors taking 3 times as long as it would on an NVIDIA machine.
That is simply the harsh reality of a maturing software stack. CUDA has had nearly 20 years of constant iteration to iron out those esoteric bugs. Neuron, by comparison, is effectively a toddler trying to run a marathon. The CUDA comfort zone, as they call it, is a very real psychological and economic barrier.
Right, because of the human capital element.
Exactly. If you hire a fresh machine learning PhD straight out of Stanford or MIT, they already know CUDA inside and out. They have never touched Neuron.
So there is a massive hidden human capital cost here. If I am a CTO and I decide to switch to AWS custom chips to save 50% on my hardware bill, do I immediately lose all of those savings by having to hire more expensive specialized engineers? Or worse, missing my critical product launch window by 6 months because we are fighting with the software?
That exact calculation is keeping every major AI CPO awake at night right now.
Yeah.
And Amazon absolutely knows this is their Achilles heel, which is exactly why they are currently pouring immense engineering resources into improving the Neuron SDK.
They're leaning extremely heavily on PyTorch, right, to bridge that gap.
Yes. Their primary software strategy right now is what they call PyTorch native. The goal, and I emphasize the word goal, is that if your AI model code is written in standard PyTorch, which, let's be honest, most modern AI code is, you shouldn't have to change a single line of that code to run it on a Trainium chip. It should, in theory, just work.
Should. That is definitely the operative word in software engineering.
It is, but it is getting much, much better. They are leveraging PyTorch XLA, which stands for Accelerated Linear Algebra, to seamlessly translate the standard code into hardware instructions. But they also know that isn't enough for the real power users. For the engineers who need to squeeze every single drop of performance out of the silicon, AWS recently introduced the Neuron Kernel Interface, or NKI.
NKI. Tell us more about how that works.
This is Amazon's direct answer to low-level CUDA kernels. It allows those high-end performance engineers to go bare metal. It gives them direct granular control over the specific instruction set of the Trainium processor.
Why is that so important?
Because previously using a Trainium chip was essentially interacting with a black box.
Yeah.
You put your code in, and if it ran slowly, you really didn't know exactly why or where the bottleneck was. With NKI, they are finally giving developers the surgical tools they need to optimize those deep bottlenecks themselves.
And they're open sourcing a huge portion of these tools, right?
Which, frankly, is the only way to build developer trust in 2026. They desperately need the open source community to jump in and help fix the edge case bugs that their internal teams simply can't find fast enough. But let's not sugarcoat the reality on the ground. The software gap between NVIDIA and AWS is still significant today.
Okay, so we have the incumbent NVIDIA defending their software moat. We have the challenger AWS attacking on price and interoperability. But is this really just a two-horse race? Because looking through the source documents and the broader market data, I'm constantly seeing names like Broadcom and Marvell popping up. Where exactly do they fit into this silicon schism?
They are the independent arms dealers for the rest of the market. What we're witnessing with them is the massive rise of the ASICs.
Application-specific integrated circuits. Just define ASIC clearly for the listener who might just think of it as a generic tech term.
Sure, a GPU like NVIDIA's flagship H100 is a general-purpose unit. It is incredibly flexible. An ASIC, on the other hand, is a custom piece of silicon designed from the atomic level up to execute one specific mathematical algorithm.
So it's highly specialized.
Completely specialized. An ASIC cannot run a Windows operating system. It cannot render graphics for a video game. It physically only knows how to do AI matrix math. But because it is entirely specialized, it is unbelievably fast and energy efficient at that one specific job.
And Broadcom is the primary company quietly designing these custom ASICs for the other tech giants who don't happen to have Amazon's massive internal hardware engineering team.
Correct. Google's famous Tensor Processing Unit, or TPU, Broadcom helps design and build that. Meta's custom MTIA chip, Broadcom is heavily involved in that architecture as well. But recently, the absolute biggest shockwave in the industry was their new partnership with OpenAI.
The $10 billion rumor. We have to talk about that.
Yes, the reports of OpenAI partnering directly with Broadcom to design and build their very own custom AI silicon. This is a massive market signal. It essentially tells the world that even the absolute crown jewel of the AI revolution, Sam Altman and OpenAI, are actively looking for a permanent off-ramp from NVIDIA hardware.
Because even with all their Microsoft backing, they simply don't want to pay the NVIDIA tax forever.
Nobody does. It eats your margins alive at scale.
So Broadcom, and to a similar extent Marvell, are essentially enabling this build strategy for any massive tech company that wants custom silicon but can't do it entirely in-house.
Exactly. Marvell is doing incredibly similar and vital work, particularly focused on the high-speed data interconnects and the storage controllers that feed these massive clusters. So what we are actually seeing unfold is a silicon schism that isn't just a rivalry between two specific companies. It is a fundamental structural shift in the entire computing market.
The bifurcation of the industry.
Yes. On one side, you have the merchant silicon market. That is NVIDIA designing one brilliant flexible chip and selling it to everyone in the world. And that model will absolutely remain dominant for standard enterprise companies, for university researchers, and for anyone who prioritizes immediate flexibility. But on the completely opposite side, you now have this booming custom silicon market. That is AWS, Google, Meta, and now OpenAI building bespoke, highly optimized chips tailored strictly for their massive, predictable internal workloads.
And the market projections show this custom side is rapidly winning ground.
Very rapidly. By 2028, custom AI chips are projected to take 45% of the entire market, up from just 37% recently. That is a massive capital swing in a multi-hundred-billion-dollar market. NVIDIA is mathematically guaranteed to lose market share in the elite hyperscaler segment. There is simply no way around it.
The real question for their stock price is whether the overall pie of AI demand grows fast enough globally that NVIDIA simply doesn't care about a shrinking percentage because their total revenue is still climbing.
That is exactly the bull case for NVIDIA right now.
Okay, let's bring all of this deep architecture and market theory down to earth for the listener. We've covered a massive amount of ground today, from 500,000 chip clusters to neuron kernel interfaces to $10 billion Broadcom deals. If you are listening to this deep dive right now and you are a software developer, what is your immediate takeaway?
If you are an engineer or a developer in this space, you urgently need to diversify your skill set. Relying solely on the CUDA comfort zone is becoming a massive career risk. As global inference costs become the primary driver of AI business models, these companies are going to aggressively mandate a move to Trainium, to Inferentia, and to other custom ASICs just to survive financially.
So you have to follow the hardware.
You do. Learning how to deeply utilize the AWS Neuron SDK or becoming an expert in optimizing code for PyTorch XLA is going to be an incredibly premium, high-paying skill over the next 5 years. You absolutely want to be the engineer who can walk into a boardroom and confidently say, I can migrate our flagship model to AWS custom silicon and permanently save you 50% on your compute bill.
That is how you become indispensable.
That gets you hired anywhere.
And what about for the investor or the business leader who is just trying to navigate this massive capital cycle without getting wiped out?
For the business side, you need to obsessively watch the efficiency metrics. Tokens per watt is officially the most important metric in the entire AI industry right now. We are hitting hard, undeniable physical limits on global energy generation. The ultimate winner in the next 5 to 10 years won't necessarily be the company with the absolute fastest single chip in a vacuum.
It will be the company that scales.
It will be the company who can reliably deploy the maximum amount of artificial intelligence per single megawatt of available grid power. That is the true bottleneck.
And do you honestly think this market bifurcation is a permanent state? We aren't eventually going to regress back to a one-chip rules all world.
The genie is permanently out of the bottle. Amazon has simply sunk way too much capital into this to ever turn back now. Google is way too deep into their PPU architecture. The pure operational economics of custom silicon at hyperscale are just too mathematically compelling to ignore. NVIDIA will absolutely remain the king of pure technical innovation. They have the budget and the talent to always ensure they have the absolute fastest, most versatile chip on the market first. But they will no longer be the only viable option in town.
It really reminds me of looking back at the traditional server market in the late 90s versus how we view it now. Eventually, all underlying compute architectures commoditize.
Exactly. We are actively moving from the Wild West phase of the AI boom, where you are willing to pay literally any price just to get your hands on a weapon, to the mature industrial phase, where the winners are determined by who can optimize for cost, supply chain reliability, and energy efficiency.
So to try and wrap all of this up into a neat bow for everyone listening, NVIDIA is still the fortress on the hill. They still command the massive software moat with CUDA, and they undeniably produce the most powerful generalized hardware in the world today.
Yes, without question.
But AWS has successfully built a massive, highly funded siege engine right outside their walls. With the Trainium 3 architecture and the sheer scale of Project Rainier, they have conclusively proven that custom silicon can absolutely play and win at the frontier model level. And by strategically pivoting to interoperability with NVLink Fusion, they are trying to essentially swallow the entire infrastructure market whole, rather than just fighting NVIDIA for scraps.
It is a very dangerous and very, very smart long-term strategy from AWS.
I completely agree. And I want to leave everyone listening with a final provocative thought to chew on as we wrap up. We almost always assume that massive tech monopolies end with a loud bang, a dramatic antitrust lawsuit, a forced corporate breakup, or some completely unforeseen paradigm-shifting technology that makes the old hardware obsolete overnight. But looking at the massive capital flows we discussed today, what if this particular monopoly actually ends with a slow, quiet migration?
A migration to good enough.
Exactly. As the entire AI industry inevitably shifts its focus from training, which is incredibly hard and absolutely requires NVIDIA's premium hardware, over to inference, which is rapidly becoming a high-volume commodity, does the NVIDIA tax simply become economically unsustainable for the global economy?
That is the question.
Right. If AWS can reliably offer 90% of the peak computational performance for 50% of the total price, and simultaneously allow you to just plug in a few NVIDIA chips whenever you really need them, does the absolute monopoly slowly, quietly, and inevitably drift away from the king?
That is the multi-trillion-dollar question for the rest of this decade. And just looking at Amazon's $200 billion CapEx bet for 2026, they certainly seem to think the answer is a resounding yes.
We will definitely be watching that multi-billion-dollar bet incredibly closely as it unfolds. But that is all the time we have for today's deep dive. Thank you so much for listening.
Goodbye.